All right. Good morning, everybody. It is Thursday, October 15th. Today we're going to talk about graphing and translating translations of polynomials. And I'm starting with graph paper on purpose, okay? So I'm going to go through and just do a real quick review of some things that we should know. So let me start off with, first of all, a y equals some x squared. Okay, and hopefully, got the general idea that should look something like this. General shape, you know, right? Looks like that. We know that, okay? And then, how about a y equals some x cubed? Well, the general shape, or the parent function, looks like this. And it's going to look something like this. Has a little bend right there called the inflection point, okay? But it can also look like this, which we've seen. It can also look something like this. It can have curves in it. It can also, depending on what it is, it can also look something like this and upside down, and a variety of those, okay? We can also look at a y equals an x to the fourth. Now, x to the fourth all by itself as a parent function looks something like this. Okay, it's just going to look like a parabola, just a lot steeper, okay? It's going to look something like this. It's going to look... So it looks like a parabola, but a little bit steeper because it's x to the fourth. However, it could have a shape like this, depending on how many terms it has in between. It could also look something like this, okay? All right. We need to revisit this before we take a look at the lesson, okay? So we're going to take these and others, and we're going to move, okay? So let's take a look at the notes, okay? So here we go. Lesson 3.7. Translations and transformations. Translations. Transformations. Of polynomials. 10-15. So, regular x cubed looks like this. Here's my parent function. 0 cubed, 1 cubed is 1, 2 cubed is 1, 2, 3, 4, 5, 6, 7, 8. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. Negative 2 times negative 2 times negative 2. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's my parent function. Again, you can put this on Desmos if you want to make sure. And what we're going to do then is take our parent function and we're going to move it opposite direction to the left, 2, and down 1. That's all we're going to do. So let me take my parent function and we're going to move it. And I'm going to take the inflection point, that's what this is called. And I'll go 1, 2, 1. And I'm going to get the exact same shape. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And here it is. I just moved it back 2, down 1. Okay. Example 2, an x to the fourth. Well, our parent function looks like this. And it goes all the way up to 16. It's super steep. So our parent function looks something like this. It's just a very steep parabola. So what are we going to do? Okay, on this one, we're going to make it half as tall, which is called a vertical shrink. And then we're going to move it to the right 1. And then we're going to take it down 4. So let's go. And first we'll move it. Okay, so let's move it to the right 1. And then down 1, 2, 3, 4. Okay? And here's what I'm going to do. I know if I go 1 times 1 times 1 times 1 times 1 is 1, but half as tall. I go 2 to the fourth is 16, but half that is going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. And I just have to have symmetry. And there it is, okay? And again, I'm not against you guys using Desmos to get these, okay? All right. not too bad. Shift it over, okay? Okay, so write a rule. So this is my original parabola, or I'm sorry, my original cubic, and it looks something like this. We don't have to have a perfect picture of it. It looks something like this. This is f of x. And what we want to do is translate this one 4 units to the right, so we want to take it that way. And then we're going to shift it up 2. And then we're going to stretch it by 3, so make it 3 times as tall. So what's the new function? So we need a new rule, a new equation. So the new equation is not f of x. It's called g of x because it's a different equation. So f of x, the new one, let's call it g of x. Okay. So the one that I want to take and move like this, let me get a different color. Is going to be 3, because there's my stretch, parentheses, x, you ready? Minus 4, because I did it to the right, and it's inside. If it's inside, we take the opposite, but it's inside to the right, 4, and then we're going to go up 2. That's our new equation. Stretched by 3. Inside is a horizontal shift. Inside is horizontal shift, but always the opposite. Cube, because it's a cubic, and then up 2. Okay. Now, example 4. Okay, so example 4, an x to the 5th looks a lot like the x to the cube, except for it's just going to be steeper. Okay, so it's going to look like this. Okay, an x to the 5th is just going to be steeper. Oops, missed it right there. That's an x to the 5th. And you can put it in Desmos, take a look at it if you want to, but there it is. So what are we going to do? On this one, we're going to do a horizontal stretch by 2, and then we're going to reflect it over the x-axis, okay? So we're going to have to do a couple of things. So we're going to do a horizontal stretch, then a horizontal stretch is going to be inside, right? Horizontal is always inside, and it's always the opposite. This is confusing, but remember, I always say if it's horizontal, it's on the inside, and it's the opposite. So I'm going to do this. I'm going to take my inside, and I'm going to stretch it by 2, which is the opposite. So I'm going to multiply it by 1/2, okay, to the 5th power. And then I'd have to take it over the x-axis. Well, over the x-axis means that all of my y values become negative y values, so we'll make this negative, okay? Now let me simplify this. This is a mess. So negative, and we'll go 1/2 x to the 5th, and let's call that g of x. Okay, the horizontal's always tricky, always the opposite of the inside, okay? And that's all I have, and then the homework is up on Canvas, and you guys can watch that and see that today, okay?